Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are going to be going through question 1.2 of the grade 12 mathematics literacy paper 2 that was written in June 2021. All right. What this question is testing is that it's testing to see if you understand what surface area is. Understanding, right? You need to understand what a surface area is. It tests to see, it checks to see if you understand what a circumference is, right? Test your understanding on circumference. It tests to see whether you're able to convert from millimeters to centimeters. It tests to see whether you're able to convert from grams to kilograms, right? So I'm going to take you guys through how we convert from millimeters to centimeters. I'm going to show you guys how we convert from grams to kilograms, right? I'm going to give you the formula, a nice formula that's going to help you guys with that, okay? And also, guys, what I've noticed about paper 2, that paper 2 is an application question. Paper 2 is an application paper, right? It's an application paper. So it really needs you guys to really understand what you're doing. It's not about substituting values into a formula to get an answer, but it's about understanding what that formula is telling you. It's about understanding what a circumference is. It's about understanding what a surface area is when it comes to a shape. What is a surface area? What is a circumference? You need to understand that. Another thing I also forgot to mention is that also this question also tests your understanding when it comes to length, when it comes to width, when it comes to height, right? It tests whether you understand what those actually mean. If you were given a crate, right? What is the length of that crate? How would that affect things that you pack into a crate? How would that affect things that you pack in terms of the height or the depth of the crate? How would that affect how you pack cans when it comes to the width of the crate, right? So this question is very, very detailed. It's really an application question, guys. So you really need to watch the whole video tutorial. Okay, so this paper, guys, is very, very, it needs you to really be well rested. It needs you to know your theory, understand your theory, right? So that you are able to tackle it, right? So for this video tutorial, guys, I'm going to take you through all the questions. I'm going to take you through the approach so that you understand what the paper or the questions are asking from you. So please make sure that you watch the whole video tutorial. Do not skip through just to get the solutions, okay? Because that is not going to help you. Because what you'll be missing when you're skipping through is the explanation. What you'll be missing when you're skipping through is the approach and the understanding that you need to focus on when you're looking at a particular question. So do not skim through the video, guys. Watch the whole video tutorial, okay? So before we get started with the video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on the notification bell so that you get notified every time I upload a new video tutorial, guys. And also please make sure that you give this video tutorial a huge thumbs up. I cannot stress this enough, guys, because that really helps the channel grow, and it helps the channel reach more learners that want to better their mathematics marks. Okay, so please do not leave this video tutorial without giving it a huge thumbs up. The plan is to get this video tutorial to 1,000 likes, so please help me reach that goal by clicking on that like button. So without any further ado, guys, let us get started with this video tutorial. So let's have a look at question 1.2. Okay. So question 1.2, guys, says that below is a picture of a cylindrically shaped 400-gram can of fish. Okay. The can is fully covered by a label with dimensions as shown in the picture, right? So the first one, it says the picture of the label on a can of fish. So We know that the distance from there to there is 73 millimeters, right? The distance from there to there is 10.6 centimeters, right? So they tell us that the diameter is that distance there, right? Which is 73 millimeters. That is the diameter, guys. Do you guys still remember what a diameter is? Okay, the diameter of a circle. So I've got a 10 of Lucky Star Pilgrims here to help me with the explanations today, right? A diameter of a circle, guys, is any straight line, right? Any straight line that goes through the center of the circle, right? So if, for example, this was the center of this circle, right? So the diameter would be that line, right? The diameter would be the line from there to there, right? Because it goes through the center of the circle. Okay, the diameter would be from there to there because it goes through the center of the circle. The diameter would be there to there, right? Because it goes through the center of the circle. So that is what the diameter is. And we're told that the diameter is that distance there. The distance from there to there is the diameter of this circle. That distance there is 73 millimeters. Okay, what about the height? Okay, we are told that the height is 10.6 centimeters. So what does that mean? So it means that the distance, right, from the top of this can to the bottom of this can, that distance there, right, is 10.6 centimeters, right? We're given that distance there, right? Okay, so let us continue. It says that you may use the following formula, right? The circumference of a circle is equal to the diameter multiplied by 3.142, and the surface area of the label around the can is equal to the circumference multiplied by the height. So it says use the information above to answer the questions that follow. Okay, question 1.2.1. Calculate in centimeters squared the surface area of the label around the can. Before we even get started with these questions, there's a few things that I want to discuss with you guys, right? Firstly, guys, let's discuss the definition of a surface area because it's very important. What is a surface area? The surface area of a shape, guys, is the amount of space covering the outside of a three-dimensional shape. Okay, I'll repeat that. The surface area is the amount of space covering the outside of a three-dimensional shape. Okay, so we've got the three-dimensional shape here with us, okay? So we've got the three-dimensional shape here. So let's understand what this definition is telling us. The definition is telling us that the surface area is the amount of space covering the outside of the three-dimensional shape. So it's the amount of space covering the outside of this three-dimensional shape. If you were to use just like a piece of paper to explain this concept, if you were to put this piece of paper around this can, this piece of paper covers the surface area of this can, right? Because it is the amount of space covering the outside of a three-dimensional shape. And in this case, the three-dimensional shape is this can, right? So this piece of paper represents the surface area of this can, okay? And then what is then the circumference, guys? What is the circumference? The circumference is the distance that surrounds the circle, right? It is the distance that surrounds the circle. That distance there, that is the circumference of our circle. The line that I've drawn in black is the circumference of our circle. It's the perimeter of our circle. It is our boundary of our circle. It's the outline of this circle. That is the circumference, okay? So now that we've discussed the definition of a surface area, we've discussed the definition of a circumference, we are more then ready to start tackling these problems. Okay, so let's get started. Okay, so this is question 1, guys. Okay, and we are tackling question 1.2.1. So question 1.2.1 says, calculate in centimeters squared the surface area of the label around the can. So what I just explained, we now have to calculate the surface area of the label around the can, right? So how do you calculate the surface area of the label around the can, right? So we are given the formula: surface area of the label around the can is equal to the circumference multiplied by height. Okay, so we first need to calculate the circumference. Once we have the circumference, we substitute it into this formula to get the surface area of the label around the can. Okay, so the circumference is equal to the diameter multiplied by 3.142, right? And then, guys, what are we noticing here? The diameter is in millimeters, right? And they're telling us that we need to calculate it in centimeters squared. That means that we need to have our units in centimeters and not in millimeters, right? So how do we convert from millimeters to centimeters, right? So we kind of remember this, guys, that, okay, kilometers, meters, centimeters, and millimeters. And you guys need to remember that if you want to move from a bigger unit to a smaller unit, we need to multiply. To move from kilometers to meters, right, we need to multiply by 1,000. To move from meters to centimeters, you need to multiply by 100. To move from centimeters to millimeters, you need to multiply it by 10. All right. And what you've done here at the top, you just need to do the inverse of it at the bottom. So if you've multiplied by 10 to move from a smaller unit to a bigger unit, you need to divide by 10 at the bottom, right? To move from centimeters to meters, because you've multiplied by 100 here, you need to divide by 100. And to move from meters to kilometers, because we've multiplied by 1,000 here, we need to divide by 1,000. Okay, so that is how we basically convert our units. Okay, so here now, guys, we need to convert these millimeters into centimeters. So let's convert these 73 millimeters into centimeters. What do we do? So it's going to be 73 millimeters, right? Because we want to move from millimeters to centimeters, we're moving from a smaller unit to a bigger unit, right? We're moving from millimeters to centimeters. Moving from millimeters to centimeters, we need to divide by 10. Okay, so you need to divide by 10. 73 divided by 10 is going to give you 7.3 centimeters. Okay, so we've converted the millimeters into centimeters, and we are ready to get started with calculating our circumference, right? So we said that the circumference is equal to the diameter multiplied by 3.142, right? So our diameter in centimeters is 7.3 centimeters multiplied by 3.142, which is equal to 7.3 centimeters multiplied by 3.142 to give us a circumference of 22.936 centimeters, right? So that is our circumference, 22.936 centimeters. Okay, but we're not done. Okay, we were asked, so this is we were asked to calculate the surface area of the label around the can, right? So the formula for the surface area needs us to have the circumference, and we multiply that with the height. So since we've calculated the circumference, we'll be able to calculate the surface area, right? So the surface area, okay, is equal to your circumference multiplied by your height. Okay, right? So what is our circumference, guys? I'm going to just put this here. Our circumference is 22.9366 centimeters multiplied by, what is our height? Our height is 10.6 centimeters, right? 10.6 centimeters, right? And we see that here we've got the same units, which is what we wanted. That is why we converted the millimeters to centimeters, right? And if you multiply the 22.9366 by 10.6, right, what do you get, guys? So 22.9366 multiplied by 10.6, you get 243.128 centimeters. Centimeters times it by centimeters is centimeters squared, which are the units that they wanted. They said that the answer needs to be in centimeters squared, right? So we've got our units in centimeters squared. And we are done. We have calculated the surface area of the label around the can. Let us look at question B. Okay, so question B, guys, it says, determine the total length of a label if an overlap of 0.6 centimeters is needed for it to be glued around a can, right? So it's very important that we understand what this question is asking from us, right? It wants us to determine the total length of a label if an overlap of 0.6 centimeters is needed. Okay, so first thing, we need to take out the can so that we understand what is required from us, right? So they want to find out what the length is going to be plus the overlap of 0.6 centimeters that is needed. So like we mentioned, guys, we said that if you have this piece of paper and you basically wrap it around this can, we said this piece of paper basically represents the surface area of this can. But now this question is now asking us, what would the length be, right? If you basically needed this length plus an additional 0.6 centimeters of length to overlap, okay? So I'm going to take a different piece of paper, right? Okay, so now we need an overlap, right? So it mustn't be fit the can properly, because you can see that with this piece of paper here, it doesn't fit our can properly like the other one did. There's an overlap, right? So that overlap there, what this question is saying is this overlap is needed, right? So we need to calculate what the length would be here, right? From there to there, plus this additional 0.6 centimeters overlap. Okay. So we've got a piece of paper from there to there. That is just the length that is needed to just fit our can perfectly. But then we also need that additional 0.6 centimeters overlap, right? So they want to find out what would be the total length now, right? So we already have that length there, right? So what's missing for us to calculate? We need to calculate that length there, right? So how do you calculate that total length? We need to get this total length from there to there. How do you calculate that total length? What is that total length from there to there? We want that length. Remember, guys, we said that the circumference of a circle is the distance that surrounds the circle. So the distance that surrounds the perimeter of a circle. So if you have a look at this piece of paper, it actually surrounds the perimeter of the circle. Don't you agree? If we exclude this overlap, right? And we basically had to calculate the circumference of the circle, we'll be able to get the distance of this wrap. We'll be able to get the perimeter that this wrap is covering, right? So if we calculate the circumference of the circle, we'll be able to get the length or the perimeter that this wrap is covering, okay? By getting the circumference of the circle, we will be able to get the perimeter or the length that this wrap is covering, all right? And how do we calculate the circumference of a circle? Okay, we calculate the circumference of the circle by using the formula that was given to us, which is diameter multiplied by 3.142. We've already calculated the circumference, right? And we found that the circumference of this circle is actually 22.9366, okay, centimeters, right? And we said that the circumference is the distance that surrounds the circle, right? So the distance that surrounds this whole circle, is the circumference, or it's the perimeter of this whole circle, which is the circumference. And you'll realize that if you actually calculate the circumference of the circle, you'll be able, if you take this out like that, right, you'll be able to get that length there, because that length there is what the circumference is, right? That length from there to there is actually the outline of our circle, right? The length, right, is the outline of our circle, okay? The length from there to there is the outline of our circle, which is the circumference of our circle. So if you take the circumference, right, and you add the overlap that is needed, you'll be able to get the total length. Okay, so what was the circumference? Our circumference was 22.9366 centimeters plus the overlap that is needed. We are told that we need an overlap of 0.6 centimeters. Okay, and if you add those two values together, you get 22.9366 plus 0.6, which is equal to 23.5366. Okay, so that is the total length of the label, right? That will be needed if you have to have an overlap of 0.6 centimeters. Okay, you see how important it is to understand circumference. Okay, you see how important it is. Okay, it's application questions. Okay, that is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.